Today we will study about the quantum number. Okay, what is quantum number? Quantum number are mainly used for to find the energy, position, size of orbital of any electron. Okay, so we are starting the study about quantum number. So first question is, what is quantum number? So quantum number, we can say that the quantum number can explain the energy, position, size of orbital of any electron which are surrounded the ठीक है outer part of nucleus. So this is the definition of quantum number. Okay, and there are four types of quantum number. There are four types of quantum number. First is principal quantum number. Okay, so what is principal quantum number? So first is this, we are representing the principal quantum number by small n. Okay, this is the symbol of principal quantum number. And principal quantum number, we can also write the principal quantum number by the, we write the principal quantum number like K, L, M, N or 1, 2, 3, 4. Okay, so on. So this is the principal quantum number. And the third work of principal quantum number is this. The principal quantum number can define the distance of nucleus and electron. Okay, this is the atom, this is the nucleus, this is nucleus, and this is the position of electron. So distance between nucleus and electron can be defined by the principal quantum number. Okay, I am giving to you example of principal quantum number. Example is this. This is the beryllium. Okay, what is the atomic number of beryllium? Is 4. So 1s2, 2s2. This is the electronic configuration of beryllium. So in this electronic configuration, which one are principal quantum number? So also remind that this is the quantum number of, this is the principal quantum number. Okay, the number of any electronic configuration which are present in the front of orbital are called principal quantum number. Okay, for 1s2, 1 is the principal quantum number, 2s2, 2 is the principal quantum number. This is the example of principal quantum number. Okay, this is the principal quantum number. And second is azimuthal quantum number. What is azimuthal quantum number? So azimuthal quantum number we can represent by L, small l. Okay, also remember small l. So this is the symbol of azimuthal quantum number. Second is this, azimuthal quantum number have a fixed value for all orbitals. Okay, azimuthal quantum number have fixed value for S, P, D and F. Okay. For S, the value of azimuthal quantum number is 0. For P, 1. For D, 2. And for F, 3. This is the fixed value of azimuthal quantum number for all orbitals. Okay, now we see the one example of azimuthal quantum number. Look at here. We are taking a one electronic configuration like of helium 2. No, 1s2. This is the electronic configuration of helium. So we know that the 1 is a n, it means principal quantum number. So n is equal to 1. And L is equal to, so define is this. Which orbital present here? S. And we write there the value of all the orbitals for azimuthal quantum number. S is equal to 0. So L is equal to 0. This is the formula to find the azimuthal quantum number for any orbital. And the another formula, the third point of azimuthal quantum number is this: the value of azimuthal quantum number is also depend on principal quantum number. Okay, the value of azimuthal quantum number is also depend on principal quantum number. But how? So look at here. The formula for azimuthal quantum number is n minus 1. This is the formula of this is formula for azimuthal quantum number. Okay, when n is equal to 2, so L is equal to n minus 1. What is the value of n? 2. So putting the value 2 minus 1 is equal to 1. When the value of n is equal to 2, then the value of L is equal to 1, because we are putting the value in formula. Okay. And one more thing you remind, the value of n will never become 0. Okay, never. So remind that. Then the third, which one is the third quantum number? The third quantum number is magnetic quantum number. This is the third quantum number. And what is the symbol of magnetic quantum number? Is small m. And the value of m is also depend on the value of L. It means azimuthal quantum number. Okay, because the formula is this: 2L plus 1. Okay, this is the formula for magnetic quantum number. Okay, look at here example. When L is equal to 1, so how many number are possible for magnetic quantum number? So you putting the value of L in this formula: 2 into 1 plus 1. 2 into 1 is equal to 2 plus 1 is equal to 3. So there are 3 values are possible for magnetic quantum. Okay, so this is the magnetic quantum number. And the fourth and last one is spin quantum number. Okay, spin quantum number. So what is spin quantum number? First, what is the symbol of spin quantum number? Is S. Small s is the symbol of spin quantum number. Okay, and second thing is this: the value of spin quantum number are never depend on the principal and azimuthal and magnetic. Okay, they are a free body. So we can write that how we can find the spin quantum number. So I will giving a explanation about it. We are taking one example. Okay, an example is this. We are taking a 1s2. It is example. So we know that this is a principal quantum number, and when the principal quantum number is 1, so L is equal to n minus 1 value putting. So what is the value of L? So putting the value of N is there. So 1 minus 1 is equal to 0. And we also find because the value of 0. So you're putting the value in the formula of magnetic quantum number. So 2 into 0 plus 1 is equal to value of M is equal to 1. So this is the formula for N, L, M, and M. But what is the formula for S? So see, S quantum number is depend on the orbitals. Okay, which orbital present there? S orbital, and we know that S orbital have two cell. Okay, one cell. One cell, it means this is a one cell, and what is the capacity of one cell to having electron? 2 electrons, and the 2 electrons are fill up by their rotation. Okay, always remind that one electron are filled like this, and this is called clockwise. And second, there are 2 electrons. One electron put it like this, and second like this, and this is called anti-clockwise. And how can you write this electrons? You can write like this: plus half and minus half. So there are two values for S: plus half and minus half. Okay. So this is the quantum number, and this is the explanation about the quantum number. Okay. The next class we study about